So in this video, we're going to talk about a slightly different approach for gradient descent. This is the approach where instead of just taking steps, sort of relatively fixed step sizes, we move along the direction of the gradient until we don't have any benefit from moving in that direction anymore. Okay, so and probably the easiest way to illustrate that is just to show you what we mean. So the sort of algorithm consists of our choosing a point to start with. Once we've chosen the starting point, we evaluate the gradient at that starting point, and then we move in that direction until we get to the point where the gradient is actually perpendicular to that direction.
The new gradient.
The new gradient. So we're going to actually be thinking about what the gradient is as we move along that line. Okay, so let's sort of choose a point to start at, and I'm going to choose what's a good point to start at? Let's choose this point here to start at. Okay, so the gradient at that point is
pointing that way.
It's pointing in that direction, right? So I've now evaluated the gradient at that point. It's that little arrow. And now since I'm pointing in that direction, I'm actually going to draw a line that shows the line that I need to walk along. So there's my line, right? And I'm going to start moving along that line. So as I move along that line, I get to this point. What direction is the gradient point?
It's off the line.
It looks to me like it's off the line a little bit there, right? Something kind of like that. And here it's off the line a little bit more, right? And as I move further along, what happens when I get to about here?
Does it become about perpendicular?
Looks like at this point, like there's a contour line here. If I sort of thought about what the contour lines looked like in between, someplace right around here, the gradient starts to point perpendicular to the line. Okay? And if you think about what that means as I'm walking along this line, I'm going uphill, 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 until at this point, if I keep walking, I'm going to actually start to go, like if I went further, my gradient actually starts to point backwards. So I'm going to start to go downhill. Right? So I'm walking along the line until I don't get any benefit from walking along the line any further. And that point is the point where the gradient is actually perpendicular to the direction that I started in.
So this would be like the little piece of the level curve that the gradient is normal to?
That's right. So at this point, the gradient is actually, at this point, this line is parallel to the level curve, and now the gradient is perpendicular to the line that we're walking along.
Okay.
Right? Okay, so we get to this point, and now we do the same thing again. We now reevaluate the gradient at this point. We say, aha, the gradient's in that direction now. So now we're going to walk along that line. And we'll attempt to make this sort of be accurate-ish. So there's my new line that I'm going to walk along. This is perpendicular. And I walk along this line, and I evaluate the gradient as I walk along this line. So you can see that by the time I get to here, the gradient looks like that. And by the time I get to here, the gradient probably is very small, but is pointing in that direction. Right? So there I'll stop again, and now I'll evaluate and walk along this line. And you can see that what's happening is I'm pretty quickly, through a relatively small number of steps, converging to this maximum. Right? And that's actually the advantage of this method, is it gets you to the maximum quite a bit faster than the sort of more fixed step size that Giordano talks about. On the other hand, of course, involves you actually knowing what the gradient is along the line. So there is certainly a trade-off to this method. Both of these approaches, as I said, there's a lot more to doing this than what we're talking about. We want to give you an idea of how this works. But these types of gradient descent approaches are one way that you can find the minimums or the maximums for a multivariable problem. One of the things that I do want to highlight here is this idea that these approaches only find a minimum or a maximum. So if you look in the MATLAB documentation, you'll find things about multi-start methods, which are basically approaches that use the same kind of approach, but instead of just starting at one point, they start at lots of different points and then see where each one ends up and then figure out what the maximum is by taking the best maximum. There are also approaches like, for example, simulated annealing, which instead of walking in this very deterministic way basically adds a little bit of thermal noise to the system, so you get shaken out of being driven to one particular maximum. So these are some of the ways you deal with the fact that these gradient descent methods only get you to a local minimum or a maximum and not the absolute minimum or maximum.
And sometimes you may not even know how many of the locals there are.
Right, and there are lots of cases you don't know how many mins or maxes there are, and so your sort of search is very is challenging to execute.